Welcome to TLS Coder. Today, Rust REST API. Rust REST API. Motherfucker! So today we're going to develop a Rust REST API, including TLS, because all these noobs on YouTube show these videos how to make a web API and don't use TLS. Well, if you don't use TLS for your development with web APIs, then I cannot really take you serious. Then you're a noob. So we're going to do it with TLS because that's what I was interested in. Because at my current customer, we may need to develop a simple API to circumvent some very slow departments and get what we need anyways without them. And they have very strong security guidelines, and I want to run it in a Docker container. I do not want to hassle with updating freaking C# runtimes. Fuck C#. I do not want to update Java runtimes. Fuck Java. I do not want to update fucking NodeJS stuff. If I build it once and it's secure, I want to keep it. And if it's secure, what do I need when it needs to be secure? Oh yeah, Rust. So let's jump in and have some Rust REST fun. Rust REST fun, right. I start by creating a directory Rust under my development folder. Go into the directory and then I call cargo init and let's call it API. And then press enter and we get the framework. And now I open Visual Code and actually open that framework that has been created, or the boilerplate, and we start by importing the stuff that we're going to need. We're going to run Rocket. So I'm downloading Rocket version 0.50 release candidate 2. That's the latest release. Can't wait for it to be finalized. And we're going to use an option that is actually to tell it that we want to run TLS. Because frankly, if you develop a web service, you give an example, do it with TLS. If you don't, I can't take you seriously. Everybody should run TLS. And now I'm also going to import SQLite, because we will make one service that actually queries a database, a very simple example. And we use this very low-level wrapper around C. And I'm here dabbling whether I should import a request or not. Eventually I ended up not using it. I was wanting to talk about integration tests as well and actually running the API over HTTPS itself. But we test that in the browser, and the unit test that we're going to create later on will just call the actual function. And that's the whole reason of an unit test. You don't really want to be tied to your web service, but you could do that. And in the code that I put up on GitHub, I actually put in all of them as well. So let's set up a profile release because I want to build this for size, so optimal size, not really optimal speed. Because this service is not going to be hit hard, so size is more of a determining factor than speed. And of course you can compile it for speed as well if you want, then generally the binaries are a bit bigger. And we make a remark that this is optimized for speed. Right, what's next? Let's create, first let's create a app config where we can hold the global configuration. Because we're going to use a SQLite database and it would be nice to have the path name in a application configuration file, that if we ever go to do CI/CD, that's the location where we just need to update it. Before actually building it, of course. So pub constant database file, and let's make that a string, or string slice actually. As testdb. Oh, I now see that I missed a dot. Later on I will fix that. This is the test case. And here I'm creating a check a DB file. It's just a little wrapper function that quickly checks whether that file is available or not. And if it isn't, we exit the process, because there is no reason to actually spawn it then if there is no database file. So if not path new and then the path name of the database file, so file name, need to borrow it, that's the ampersand, dot exists. Oh, my typing is brilliant. I never could type. And then we do an error print line. Well, something went terribly wrong, blah blah, whatever. Could not find database. I can live with that as well. Database file. And let's add the error description in there as well, since we're working on it anyways. So the database file, the file name, sorry, not the error description. And then we call process exit, well, 1, so we exit with an error. And I need to import that. Oh, here I missed a colon. Hey, the process. So let's go to the main and let's import the macro for Rocket. So macro, square brackets, macro, use, and then extern create Rocket. And this just comes straight from the Rocket documentation. Now I have some weird squigglies. We'll solve those later on. Let's import the app config. We're going to use that module. And we're not going to use main. We're going to use this launcher macro or compiler directive, which actually creates a sort of a main, and it will actually read or polls the await that is part of the Rocket API. So we just launch Rocket, return underscore app config. Here we're going to test if that file is available, because if that file isn't available, there is not even a reason to spawn this service. Well, in this case it may be because we have a service that is not database dependent, but usually all your databases, all your services in this case would be database dependent. I found a typo, and I found that I also needed to import use std process right there, and now that is fixed. Let's go back. And then we bind Rocket, so Rocket build .mount, and then the base API slash, oh, I forgot a backslash, I see now, I'll fix that later on. And the routes, this is a vector that holds all the routes. We're going to be filling that in as soon as we actually implemented the routes. So now let's create actually the API version 1.rs. It's always good to have API versions, because you tend to need to change the interface at some point, and you want the old version to be running as well. And probably you want them in the same code base. You do not really want two different code bases for two different versions. And this is one way of doing it. So just creating a module version 1 and a module version 2 if you have them, and you can bind them or mount them, that's the Rocket word, in the same routing. So here I use actually prefix it with /v1. So in my endpoint it actually takes this version along. And then I have test, which is basically a package name. And in that package we have the say hi function, and it takes a name and an age. So we now come to implement this. Oh yeah, they need to be between larger and smaller than brackets. So I take the name as a string and age as a U8 from 0 to 255. I think that covers pretty much every age. And here I make a match block. So I match age, and then this allows me to sort of have a guard clause if block, because I have several ifs that I have. So here I'm using a match block, which basically creates a set of if guard clauses. So I have ranges of ages that gives a different reply. So I format that, and that's the string that we return, depending on that age. Actually, I see that I made a typo, age colon, copy and paste errors, that's what you get. I'm looking here like, why is that? And it took me a bit to figure that out. So usually when I have an error and I don't immediately see it, I just continue on coding, and then either the compiler will help you, and in this case I was like, oh my god, that colon there. I don't need a type. And even if I needed a type, I forgot it there. And this catch-all, you need to put it in there for some reason, even though this is completely caught. But yeah, that is Rust. And I need those errors, those arrows. And I noticed that my path was wrong. I was missing this slash API v1. And this reminds me, you need the nightly build from Rust. I always use the nightly build because I really like the development that's going on. If you don't, your Rocket doesn't compile. So let's do a build now, see how far we get. Because we coded a lot, usually I compile more in between. But for a video, you want to keep the pace in there, you know? A Rocket. And the first time compiling always takes a bit long because all these modules need to be compiled, but then they're cached. And yeah, so it's satisfied. We don't have a database, so let's create a database. So we type SQLite 3. We give the name of the database file, so testdb. And we done just create a table. Let's do a test, and let's give it a name, varchar 255, and a description. It's really all about demonstrating it. Varchar 255, there we go, semicolon, boop. .q exits, and it is created. So if you now cargo run, it still fails. Oh, I'm missing the dot. So off screen I quickly added the dot in front of the file name, and now let's do a cargo build, and it should actually build. And by the way, this code is almost written real time. It took me about an hour. And for some reason TLS is not enabled. I expected to get an error because I did not create the certificates, but it seems to then bind just as ordinary HTTP, which is okay. So let's create a self-signed certificate. I quickly Googled for that single line command to create a self-signed certificate. OpenSSL is one of those packages that I use a lot but never can remember all the enormous parameters. So we have a certificate and a key. Okay. Oh, I need to put in a passphrase. Can I leave it empty? No, I can't. This means I need to unencrypt my PEM file because Rocket requires an unencrypted PEM file. If you put a password in there, it's encrypted. So let's fill in the country, NL, state and province. I live in Utrecht. Locality Nieuwegein. This is just as bad as my typing. Nieuwegein is. Phonex, that's actually my company. And let's, the CN name, Phonex. Oh, damn. Oh, this is the CN name. Let's use that. It's self-signed anyways. api.phonex.com. And I will put this in my host file as well. And an email address just in case it requires it. Okay. So now I need to look up how to actually decrypt it. First be verifying that it is encrypted, but I think it is. So let's have a quick other Google search how to decrypt a key. And the thing is that you need to know how SSL works and all these commands. You can Google them, you can read the documentation. Google generally is faster. So let's see. Oh my God, that's a lot of documentation. And this seems to be what I need. Yeah, oh, that's actually easier than I expected. Let's open the terminal again. Open SSL pkcs8-in, the encrypted file in, which was key.pem, yes, and dash out. Was it? Yeah, dash out. And let's call this key.unencrypted.pem. Yeah, press enter. It should ask us for a password. It does, yeah. And then it can strip away the encryption. So now we have the unencrypted here. Yeah, that's good. And this will satisfy the rocket.toml. So let's create the rocket.toml. We just need to create a global.tls section and then tell where the certificate file is located and the key file. So cert equals search, it's plural, weirdly enough. / oh my God, my typing. Cert.pem that we add, and now key, and we need to pass in that unencrypted key. Key. I really should take a typing course. Key unencrypted .pem. I may not be the fastest typer, but I'm a very quick developer. All right, that should work then. Let's run a Garco run and see if it is TLS, HTTPS. I already saw it there. Yeah. And TLS is, where is it? Enabled. That's what you really see. But below you already saw HTTPS 127.001.8000. So let's start Safari. And we're just going to trust this self-signed certificate. So we can actually test the API from a browser, and then we can make our unit tests that actually call these functions from basically their functions without the HTTPS layer. So yes, I know this is potentially dangerous, but yeah. And I already created a hosts file entry where I added 127.001 as api.phonex.com. And here I made a typo, so let's fix that. What did I do wrong? Good. Seems to be there. No routes. Oh, yeah, we forgot to add the functions into the routes vector. So API v1, and we have a say hi. Let's start with that. Let's cargo run it. Why API v1? Oh, I need to include the module. Mod API v1, yes. And still squigglies, why? Huh? It is there, the API v1 and say hi. Is it public? Did I forget something? Well, sometimes you just need to save your files. I don't have save all enabled apparently. So when I saved this one, it started building. Yes, there we go. And let's run this. You are experienced but not yet old. But when I'm 80, hi Ray, you walked with the dinosaurs. Well, I thank you. Okay, so this works. Now let's create that query function. So it's another public event query, and let's annotate that also with a rocket path, and we take in a name, so we're going to query that name in the database, and we return a string with all the records. So here the annotation, square brackets, array, square brackets, get, and the same thing, we want that version in there, the package name, and then the actual function query, and a name. Now, working with SQLite and Rust is a bit dodgy because obviously they're bindings. So a lot of very low level stuff still leaks out. So here again, we do that check DB file that we created in the app config, because if it's not there, then there is no reason to run this function. So this is basically our first error handle. And then we set up a connection with SQLite connection, open, sorry. And then the same DB file name, so we can use appconfig database file. There we go. And we could unwrap this here or use an exception, because we already did the error handling with checking the existence of the file. So if something isn't right in this case, then that database file exists but is no longer readable, and for whatever reason. So this would actually be enough to send us on our way finding it. So now we need to make a result variable that's going to be a string that holds all the records that we format in a nice text string. And to string, yeah, because it's a literal otherwise. And then you get a string slice, so that's why you need to use that toString. And now we're going to prepare a SQL statement. So let's do a select star from test, where name equals question mark 1. That's a parameter, and it's select. Oh my God! Yeah, there you go. And we could unwrap this as well, but with a prepare statement, you actually want error handling. So let's again use that match block. So let's give it a variable that will get the statement. So a statement, and then match it, and then we start that block, and first we catch the OK that holds an object, a statement object, which we call statement, and we return with the arrow operator, or the lambda, however you want to call this, to a statement, and then we have an error as well, statement. I like those names to be the same error, and then the E that contains the error, and also an error operator and arrow operator. And let's do a return to the browser. So we're going to return a formatted string with this error. So a problem with query. And let's dump the whole contents. That is the colon question mark operator of E, because I really don't know what is all in there, but let's send it all back to the browser. And we need to have those commas and a semicolon. So now we error handled also the prepare statement properly. So every error case is covered. And I have brackets too many. Yeah. Okay. And now we need to set the bindings for the parameters. And we need to have a mutable statement that we get back, because later on we will call a next operation, which will actually mutate that statement. So let's match the statement, bind, and variable 1, and then name. And now that I look back, I immediately see that I needed to borrow this. What you will see in error in a second. So okay, and again we take in that statement, or we get the statement, yeah, whatever the name we want, and let's return that to T, or return that statement to T, yeah, I said it correctly. And we need to have an error as well. So T can now be mutated by the next modifier that we're going to use, or next method. But first let's catch this error, and let's do the same. Let's print it back to the browser, informing it what went wrong. So arrow, and then the function, and let's do a return, and let's copy this whole shizzle. Right, argument fold error, whatever, and return the whole string. Okay, and we need a comma there and a semicolon below. Right, and now we can do the while loop and iterate through the result set. So let's state read row, and I think we need to import that state. Use SQL state. There we go. So that should satisfy it now. Equals t.next. And let's unwrap this here, because error handling in this stage, since we already got a SQL error and we already caught a potential argument error, well, if we have an error here, it's so severe, just let an unwrap message tell us what is happening so we can debug it. Oh, an accept, it's not an unwrap. Well, let's use the accept, which basically behaves the same as an unwrap, but then with a nice message. Now I need to think, because this next operator is a bit of a bitch, because it returns a pointer. So let me first set up the result, the name, and then we need to have the t.read, I believe. Read, yes. I'm digging in the knowledge that I had of using this with C in the past. And I don't want to put in an iterator. I think I can just return a whole string. Yeah, it seems to be allowed. The linter in Rust is really good. It's quite incredible. So we take column 0. That's also weird. You can only use indices in this case. And we return that as a string. And that should be allowed to concatenate. Looks like it. Description. And we get that from column 1. And we also translate that into a string. So yeah. Awesome. So that should actually be it. Yeah. And of course this result can also be empty if there is no match. So if result is empty, let's send back a friendly message, no records. So we set result to be no records found. Awesome. And then we just return the result. And there is no need for a semicolon because it's the result. Okay, this should work. Let's build it. And of course there's an error. The trait bindable. Ah yeah, it's the %. We need to actually borrow this from name. Yeah. And now it should satisfy the build. Oh yes, the % pointer. Because you get a point. Yeah, this is so low level, stupid C wrapper. So even the second time around when I saw it, I was like, oh yeah, still did it wrong. But you borrow a dereference pointer. And that's just the way that this stupid wrapper lies around the C function. So we need to, of course, add it to the routing table. No wonder we don't have it. API v1 query. And now when we build it, it should be there. And let's query Raymond. And there should be nothing, so it should say no errors found, no records found. It does, cool. Now let's insert some records. SQLite 3 and the database name test.db. Insert into test values. Raymond, that's my name. And I'm a developer in my company. And Raymond, but I'm also the CEO in my company, also the CIO. And then we have Renee, who is a developer. Right, okay, cool. Let's see. Let's find me. I'm missing the clear lines. Let's add those. That's one of the things that I don't really like, is that you cannot really do multiple concatenations on a string. So you have to do it on a new line. It keeps it very readable though, but makes it very verbose. I would rather want to actually format this, but I have not found a way to satisfy format, as I'm demonstrating here, with this string slice. For some reason, I cannot get it to work. Not if I dereference or borrow it, or when I dereference it with a pointer and borrow it with a pointer. So if somebody knows, because I'm learning as well, let me know in the description, because this would clean up a string format so much. But in this case, I have no idea how to satisfy the compiler. So we're just doing stupid string concatenations for now. For the demo of making a nice web service, that's enough. So let's run it again, and there we go. Oh, there needs to be a space in between my name and the description. So just copy this and just add it there. And let's add a space there. Okay, now it should be really nice. Rebuild it. And luckily the rebuild is quite quick when it's done the first initial build. Yeah, there we go. 2 records. That is good. So now let's be some good boys and finally make some tests. Usually you would make them before, but yeah, this is more an instruction video, so let's do that. Square bracket config test, square brackets around it, please. And there shouldn't be an exclamation mark there. Use super, because as you saw, all these modules are in our parent class. Use super. And then we can annotate a test with hashtag outside, please. Yes, test. And then we just create a test function. So fn underscore test, say hi. And we're calling that function that usually is called by Rocket Wrapper. So this is how you do a proper unit test. You decouple yourself from the actual web layer. I also wanted to do something with requests, but this video is already getting quite long, to do integration testing, that you actually hit that layer. But in the source code down in the description, that is all there. So we say hi, we give in the variable array, age 80, and then it should contain a dinosaur, I believe, and that was the ultimate burn. You walk with the dinosaurs. So this should work. Let's do another test if we're 49 and then, but not yet old. That only takes 4 more years of 4 more years, no, 8 more months, then I'm old. Right, but not yet old. Let's copy this and let's do another test case, an edge case, which is 30, which should be the same. And then we copy one and do one for the 29, the inexperienced noobs. I feel like a boomer. 29. And that should contain the word noob. Oh, no, I wrote it in. I wrote it as a boomer. Double O. Yeah, there you go. Okay, let's run the tests. Oh, we have an error. What was this? Oh, yeah, that exclamation mark shouldn't be there. I already said so myself. Come on. Yes, good boy. And there we go. We have successfully tested this. So let's create the test for the query. So annotate the test, square brackets. And then function test underscore query. I think that's a good name. My lack of more imagination. And let S be a query, and we put in my name, Raymond, and then we should have a result set. I need to put in as a string, to string, sorry, go on, to string, otherwise it's a literal string slice, there we go, to string. And then I can assert it, and I should be it should contain a CEO and a developer. Right. And let's copy this whole thing and do a check for Rene. That should not have the developer, the CEO role. He does have the developer role. Good developer. Yeah, seems to work. And let's check it here again. Yeah, it absolutely works fine. So there you have it. In about an hour, I cut it down to 30 minutes, but in about an hour, I developed this, including the test case, even the integration tests that actually connect to HTTPS, which is not really something that you should make as a unit test. Unit test you want to run independent from your code. So you do not want to run first the service and then test it. No, you can actually test the API itself, and that's sufficient. And you can have integration tests and monitoring that runs these integration tests continuously. I am very impressed with Rocket. It's very easy. It's almost as simple as C#. And yeah, even the dodgy SQLite wrapper, that is not really that pretty. It's not really that Rust-like. You see that a lot of the low-level C details leak out. But yeah, we got it to work anyway, so yeah. I am happy with REST. So I hope you learned something, and now I will have some rest, and see you in the next one. By the way, there will be 2 more Commodore 64 assembly videos, and I'm currently doing a lot of Amiga development. I never owned an Amiga in the past. I had a Atari ST, this Atari ST. But I have several Amigas now, and I want to play with the copper, and I'm already doing the copper bar things and the sine waves. So I think there will be a couple of videos on that as well. Because 68,000 assembly is fucking awesome. One of my favorite CPUs after the ARM. So I hope you learned something, and see you in the next videos.